It's becoming increasingly more obvious that flat earthers, young earth creationists, evolution deniers and general conspiracy theorists are trying their hardest to hurt my feelings. And I hope these comment videos will go a long way in telling these people, or showing these people, that they're never gonna do that. Hello all and welcome along to another comments video with me, Simon Dan. Thank you very much for joining me. Yes, we once again dip our donuts of debate into the glaze of opinion that is the Simon Dan comments section. I've got another 18 beauties for you today, possibly the best one yet. Right, let's do this, and we start with Earl Wilson, who says, Simon Dan, you are a goof, mic drop. I am a goof? What even is a goof? Let's just... I see. I assume you mean the foolish or stupid person meaning. Okay, well let's just shelve that one as one of the weakest attempts at hurting my feelings ever. We move on to Ross Eason, who says, you're a walloper. A walloper? What the... Okay, I need to look up this one as well. Ah, I see. A Scottish slang term for a penis. Very nice, and original too. I like it. Right, who have we got next? Ah, here we go. It's GS. What have you got to say? All the stress and shilling is taking its toll. Your globe is dying, same as you and your lies. Well, I guess in a way we're all slowly dying, aren't we? And if you think about it, the Earth is too. Nothing lasts forever. I'm not lying though, and I'm certainly under no stress. Next up is John Watson, who says, Spammy Dan is looking more gay every day, lol. Well, I'm glad you find yourself funny, John. But the thing is, so what if I am? My sexuality has nothing to do with how I am as a person or how right I am about the shape of the Earth. I'll give you your dues on Spammy Dan though, John. Not heard that one yet. Oh, and by the way, it's absolutely okay to come out and say that you're homophobic. You don't have to disguise it in a comment. Right, next up is Papa Legba, who says, Simon Dan looks increasingly scruffy and unhealthy every video. Why is that when he should be making big bucks off his channel? Could he be just a blackmailed idiot? Whatever. No way he has $5,000 to give away. He looks like a homeless panhandler. Ah, thanks Papa for your input there. Has anyone ever told you the age-old adage that you shouldn't judge a book by its cover? You see, I know the person in your profile photo there isn't actually you. And the reason I know that is because the person who it actually is has emailed me to say that you're using his picture without permission. So at least I've got the balls to show myself on screen, Papa, which is more that can be said for, well, you. The next person to comment is S. Elena, who has this to say. Ha ha ha, OMG, you are so funny. Not really, you are just an over-rated YouTube promoted shill. I may be overrated, yes, and I may sometimes be promoted by YouTube if my video is good enough. And of course, humour is subjective. If there's one thing I've learned from my time on YouTube, it is that you will never, ever please everyone. And that's okay, I get it. So, sorry about that, S. Elena. Okay, next up to have their say is MindGame261, who says this. This channel is as useless as Joe Biden. No mistake here, you'll see why soon enough. You should be ashamed, you've made a deal with the devil. Oh wow, that comment has aged horribly, hasn't it? And how can I make a deal with people or things which don't exist? Baffling. I hope Nurgle has something more interesting to say. Milkman Dan spamming the YouTube algorithm for traffic with a useless never-ending survey. What a blowhard. Get bent, you self-righteous. Milkman Dan, I like this one, well done. I assume Nurgle here is referring to the time that I did a Science World Cup using the poll system on the YouTube community page. I like that. Thanks for reminding me, Nurgle. I'm going to have to do another one of those. Cheers. The next comment comes from, it's Papa Legba again. Here we go. Come on. This gibberish makes flat earthers look sane. Poor scruffy old Dan reduced to discussing sci-fi nonsense with two other losers in his freezing bachelor flat. Lol. Freezing bachelor flat? But I thought I lived in my mummy's basement. If you want the actual truth, my office where I record here is a converted garage. Look, you can tell by the dividing wall here. Oh, and look, here's the utility room. Just a bit of context here, people. Papa Legba is constantly commenting on this channel. He often uses my real name as a way to try and spook me, and he constantly claims that I have never passed any GCSE exams ever. Well, how about this, Papa? I'll happily join a Zoom call with you where I can show you all of my GCSE certificates. However, there's one condition. You have to show your face. I guess we won't be hearing from you. Let's move on and go to Mark Gillick's comment. Away you go. Nothing also. You're a slimy nerd who likes to make fun of others. Get out and play a sport where you can get your ass kicked. Slimy nerd? Okay, I don't mind being called a nerd because I kind of am one. The sport one always gets me though. I played football/soccer for 25 years. Sometimes twice on a Sunday. I was regularly kicked up and down for 90 minutes. And now I run marathons and ultra marathons for fun. Is that enough sport for you? Next up we've got good old Dean Wright. What has he got to say? Yet another shite video made by a team of 13th Signal 77th Brigade paid trolls. Simon Dan has the charisma of a damp rag. A damp rag is an upgrade from a fermented egg though, Dean, isn't it? Just saying. And what is this 77th Brigade that I keep seeing? I'm going to have to look this one up as well. A media and psychological operations group for mind control. Right. Fermented egg, Dean. Right, who have we got next? Yes, it's Fairs of Arabia. Away you go, good sir. No one give me the time of day then, Man Dan. Rightly so, you are so full of it. Man Dan is an old one, buddy. Catch up. Let's see if Foobag969 has anything better to contribute. This is borderline religious persecution, and the fact that you're such a snide little bitch about it makes it even worse. Leave those poor bastards alone. Yes, I am quite snide for these videos, aren't I? Of course, this isn't the real me, and I'm deliberately that way for the camera. If you want to see the real me, check out the Simon Dan podcast channel, where Katz and I regularly chat with a buttload of guests. Yes, what a transition. Thanks, Foobag. Okay, next up, let's say, is Zach's Corner, who says, did you get forehead implants? Nice. No. No, I didn't. Strange. Let's move on to Logical Observations, who says this. Scam Man Dan, the NASA DILL. Oh my days, Scam Man Dan was one of the originals. 2 out of 10 for that. And 2 out of a NASA DILL. Love those guys. Okay, moving on, we've got Ken Thompson, who says, I can imagine this guy at school bullying, mocking and poking at anyone who said something silly in class or who held a different view to his. Drop it, won't you? You have your opinion. Let them have theirs without you publicly humiliating them. Actually, I was kind of okay in school. I didn't bully anyone, and I wasn't really bullied much myself, apart from the usual banter. I do mock flat earthers now though, yes, because, well, they're flat earthers. Our penultimate comment comes from someone called Two, who says, who is this Professor Dan? P.S. Telling that we come from apes. Well, I think he does. He's missing a cell or two up there. Missing a cell or two up there? Well, it is true that most apes do have less neurons in their brain than we do. However, African elephants have more, so your argument kind of falls flat on its face. And I'm no professor either, but I think you know that. Okay, our final comment comes from North Paw. I wonder what they've got to say. Is this nerd supposed to be funny? Oh boy, people are truly lost. North Paw. What I said earlier applies now. Humour is subjective. You obviously don't find me funny, and that is fine. Some think I'm mildly amusing and some find me hilarious. At least that's what my wife says anyway. Either way, the humour in my videos are a bit of a Brucey bonus. The real meat of the video is the science and the debunking. Well, there we go, another pathetic attempt for the commenters to hurt my feelings. I'm sure we'll get a fresh batch next month. Thank you all so much for watching. Remember, if you enjoyed it, please do smash the like button and subscribe as well if the feeling takes you. I have been Simon Dan. Have yourselves a great day, and I'll see you in the next one. Bye bye.
This video is Simon Dan's attempt to debunk a video by Dave Wise called Sunsets Prove flat Earth. And as you'll see, Sciman Dan does it very poorly, just like he does with all the flat earthers that he tries to debunk. So let's check out what Dan has to say here.
So DITRH thinks that the sun is small and very close. Fine. Let's get into his Sunsets Prove Flat Earth video, shall we? Okay, so DITRH is a firm believer in the model which claims that the sun circles above the flat Earth below, which means from any location the sun would be moving away from you during sunset. Of course, what he fails to point out is that when something is moving away from you, then it should be getting smaller.
Well, Dan, you've said it. You said if something is moving away from us, it should be getting smaller. That's what this sunset's doing. Here's another one. Let's see if this is moving away. Oh, wow, this is getting smaller too. If we were orbiting a giant sun, this wouldn't be happening. I mean, you can see the sun moving away, and you can see it getting smaller. Sciman Dan, I think you have debunked yourself. Dave Weiss is right. It's a small sun that's orbiting us, because you can clearly, with your own two eyes and anybody else, can see that this sun is moving away and it is getting smaller. See, look at this one. It's just, there it is. It's about to disappear out of your perspective. It's getting smaller and smaller. Here's another one. Yeah, this one here is pretty big, man. Maybe this one won't get smaller. Let's see. Well, it looks like it's slowly shrinking. It's moving away from us. So according to you, Sciman Dan, if it's moving away, it should get smaller. So the sun is moving away from us. I think you have debunked yourself, Sciman Dan. You've debunked yourself.
Look at this! This area is filled with books about pretend people!
That's right, Grover. This is the fiction section. Fiction means it's a made-up story. Fiction means it's a made-up story.
I was going to say thank you very much. I mean, that's, as a science journalist, my question is, through your career and your writing and your acting, you've inspired so many people to enter the sciences. How do you balance science with science fiction? They're both the same.
Is the law of density relative to mass.
Today, I'm going to show you a simple science experiment that you can try at home to learn about density. Start by taking an empty glass and tip in some water and food colouring. Then add some syrup or treacle. And I'm going to add a little bit more water to make the layer a bit thicker. Then finally, fill the glass up with some oil and leave it to settle for about 15 minutes. These liquids separate out into different layers because they're different densities and they don't mix. The syrup has the highest density, so it sits on the bottom, and the oil, which has the lowest density, rises to the top. Try dropping different objects in to see what happens. If we drop this metal nut in, which is really dense, you can see it sinks right to the bottom. But if I take this grape and drop it in, it sinks through the oil and water, but sits on the syrup. This is because the syrup is denser than the grape. Pretty cool, huh? Now if I take this plastic bottle top and drop it in, it slowly sinks through the oil and sits on the water. And finally, if I take this piece of sponge and drop it in, it sits on top.
It is a scientific fact, verified by undisputable evidence, that when objects are placed in mediums with less density, they sink, and when placed in mediums with higher density, they rise or float. For example, a rock in water will sink because the object's density is greater than the water's density, as will a ship's anchor. Likewise, helium-filled balloons rise because they are lighter than the air. Submarines float on the ocean when their ballast tanks are empty and contain air, and they sink when their ballast tanks begin to be filled with water. This is how they manipulate their depth in the ocean, by adjusting the ratio of air and water in the tanks. This is proven by filling a balloon with 50% air and 50% helium. As helium is lighter than air, and the ratios are even, the balloon remains fixed in the air without rising or falling. Again, much like the Earth's curve and spin, we do not witness smaller objects on Earth gravitating and orbiting around or being pulled towards larger objects. It seems very convenient that gravity's tendency to make smaller objects orbit around larger objects is exclusive to the globe itself and all the supposedly surrounding planets and stars, none of which we can actually see in motion or orbit. Even when you study the claims made by the scientist magicians of the so-called planets and moons, their calculations begin to work against them. As Eric Dubay pointed out, Newton also theorized, and it is now commonly taught, that the Earth's ocean tides are caused by gravitational lunar attraction. If the moon is only 2,160 miles in diameter and the Earth 8,000 miles, however, using their own math and law, it follows that the Earth is 87 times more massive, and therefore the larger object should attract the smaller to it, and not the other way around. If the Earth's greater gravity is what keeps the moon in orbit, it is impossible for the moon's lesser gravity to supersede the Earth's gravity, especially at Earth's sea level, where its gravitational attraction would even further out-trump the moon's. And if the moon's gravity truly did supersede the Earth's causing the tide to be drawn towards it, there should be nothing to stop them from continuing onwards and upwards towards their greater attractor.
There's a growing anti-intellectual strain in this country.
Ultimately, Newton's gravity erased the common sense of up and down, and in its place normalized the preposterous idea that this is possible. And this. And that meanwhile, in Australia, this is nonsensical, pseudo-scientific mockery and nothing more than an invention to justify the spinning spherical Earth hoax. Without the theory of gravity, not a single person in their right minds would ever believe the Earth a globe, with some of the population existing upside down on the underside of the planet. This is all quite simple once you start to break away from the toddler years of matrix programming. The laws of perspective and density perfectly explain the natural workings of our world. They invent complex concepts such as gravity and ridiculous spinning spherical networks of incomprehensible figures and speeds to bamboozle us. Is to ascend 121,000 feet and left its fisheye lens behind. Lo and behold, a flat horizon. The balloon wobbles and spins, but the horizon remains dead straight, not curving in any way, shape or form. And this is the problem. For centuries, our ancestors used their own judgment and relied on their own natural-born senses to discern that the Earth was flat. And although some had dabbled in theories of the Earth's potential curvature, it wasn't until the early modern period, with voyagers like Christopher Columbus, that the heliocentric globe model became dominant and humans forever sacrificed the knowledge of their own senses. And the heliocentric model is so blatantly flawed and nonsensical that it's astonishing that it even gained traction. Take the water bordering our horizon, for instance. It is the natural physics of water to find and maintain a level, and it just so happens that that level is flat. If Earth was a spherical ball, water would not maintain such consistent flat levels. We are used to water doing this and this, but we have never in all our lives on Earth witnessed with our own eyes water do this. Water does not bend. It's not called sea level for nothing, you know. And if water did not always find a flat level, then why would we use tools such as this to achieve accuracy? Again, water does not bend. Rivers, for instance, always run down to sea level. If Earth was a rotating ball, then inevitably many rivers on Earth would, at some point in their journey, have to flow uphill. As Eric DeBay points out, the Mississippi is 3,000 miles long, which means it would need to run uphill for 11 miles on a globular Earth. He also points out that a portion of the Nile runs for 1,000 miles with a fall of only 1 foot. Again, if the Earth was a spherical ball, this would be impossible. The scientist magicians of our world claim that the Earth is 25,000 miles in circumference. But spherical trigonometry dictates that the surface of all standing water must curve downward at 8 inches per mile, multiplied by the square of the distance. That means that a 20-mile stretch of water would dip 66.68 feet on either side of its central peak. Every time scientists have tried to find these dips and bends, however, water always proves to be completely level and flat.
There's a growing anti-intellectual strain in this country.
For this, they call it gravity.
And by the way, this is called gravity.
The scientists magicians are at it again, weaving their spells and telling us tales of a powerful force keeping us rooted to the Earth. If gravity was such a powerhouse, then birds would struggle to fly. Insects would not be able to use wind to navigate. Monkeys would not climb and jump among trees with ease. Planes would not be able to take off from the ground. Trees would not be able to overcome gravity's pull when their growth towards sunlight and would begin to bend towards the Earth the taller they became. And if gravity exists and has the power to bend and wrap the oceans around a gigantic spinning ball, then humans would certainly struggle to lift their arms and legs. Legend has it that an apple fell on Newton's head as he sat under the tree, and this was the catalyst for his great discovery of gravity, which claims that objects are attracted to large masses and gravitate towards their center. However, when they talk about gravity, what they are actually referring to is the law of density. When building railway tracks, roads and bridges, architects and engineers never account for any curvature. Engineer W. Winkler was published in the Earth Review regarding the Earth's supposed curvature, stating, "As an engineer of many years' standing, I saw that this absurd allowance is only permitted in school books. No engineer would dream of allowing anything of the kind. I have projected many miles of railways and many more of canals, and the allowance has not even been thought of, much less allowed for. This allowance for curvature means this, that it is 8 inches for the first mile of a canal, and increasing at a ratio by the square of the distance in miles. Thus a small navigable canal for boats, say 30 miles long, will have, by the above rule, an allowance for curvature of 600 feet. Think of that, and then please credit engineers as not being quite such fools. Nothing of the sort is allowed. We no more think of allowing 600 feet for a line of 30 miles of railway or canal than of wasting our time trying to square the circle.
It's a growing anti-intellectual strain in this country.
If the Earth was actually rotating, then helicopters and balloons would only need to hover over the surface and wait for their destination to come to them. Similarly, if it were a curved spaceball, then aeroplane pilots would constantly need to readjust their altitude downwards so they did not continue straight and start heading out to space. They would have to descend 2,777 feet, or over half a mile, every single minute. This of course is not the case, and pilots are never instructed or taught this mechanism of flight. And what does a real pilot have to say about it?
Oh, okay. Am I allowed to say hi? Hey, I just want to say thanks for the smooth flight.
Right.
I did have one question. Is there like a specific angle of downward tilt you have to fly at to
3 degrees.
3 degrees for the curvature of the Earth?
Oh, for the Earth?
Because
No, we just fly over the troposphere.
Really?
Yeah.
Do you have to keep like kind of going down because?
No, we actually have to nose up. It flies. Yeah.
Really? Because I was reading some stuff on the flat Earth that made a lot of sense. Have you looked into it?
Which one? Sorry?
I was reading a lot of stuff on the flat Earth.
Okay, yeah. True.
It's true?
Yep.
Okay,
Yeah.
alright, cool. Hey,
Alright.
God bless, brother.
Alright, have a good one.
You too.
Crack on. I just got one question to ask. Flat or a ball?
Flat or a ball? What's that?
Well, I never feel as breaking round. If we live on a ball, surely we'd have to fly around it. Yeah, it feels like flat or a ball.
Flat, not a ball. I think it's flat.
Yeah, me too.
Pretty flat to me.
It certainly does, doesn't it? And you've got that flight instrument down there to keep it flat.
Gravity exists.
Gravity? There's an unproven theory.
No, it's not.
Let's rock and roll. Cheers, fellas. Thank you very much for the...
Can I ask the pilots one question?
First officer's here.
Do you mind?
He's got a question for you.
Oh, yeah. Hello, mate. How are you?
Yeah, good.
I'm a fellow, Casey Josh, I'm a fellow, just PPL, pilot, yeah.
Yeah, nice.
I got a couple of serious questions to ask you.
Okay, here we go.
Yeah, there's a big time. Curvature.
Curvature?
Yeah.
Yep.
We don't allow for curvature, do we?
For anything, not for you usually. Yeah.
No, we're round, we're a disc, aren't we? Round and flat.
Yeah.
Sorry. Hey, look, honestly, quite seriously,
Yeah.
we are, aren't we?
Yeah.
Thank you, mate. Thank you for being...
If the Earth is actually rotating, flight paths would become very messy. Flying west from New York to California is 2,441 miles, which takes just under 5 hours on a commercial flight. If the Earth is spinning eastwards at 1,000 miles per hour, then not only would this flight take a lot less time, but it would also make it near impossible to fly back the other way due to the constant rotation of the Earth. It would be like trying to run up a very long and very fast downward escalator. And what about the weather? If the Earth and atmosphere is spinning at 1,000 miles per hour, then don't you think it would be impossible to see such stationary clouds and weather formations like we do? Not to mention that clouds often crisscross in their pathways. This would be impossible if the Earth's spin was a reality. Thomas Winship states, "Let imagination picture to the mind what force air would have which was set in motion by a spherical body of 8,000 miles in diameter. which in 1 hour was spinning around 1,000 miles per hour, rushing through space at 65,000 miles per hour and gyrating across the heavens. Then let conjecture endeavour to discover whether the inhabitants on such a globe could keep their hair on. If the Earth globe rotates on its axis at a terrific rate of 1,000 miles an hour, such an immense mass would of necessity cause a tremendous rush of wind in the space it occupied. The wind would go all one way, and anything like clouds which got within the sphere of influence of the rotating sphere would have to go the same way. The fact that the Earth is at rest is proved by kite flying. And honestly, if the Earth was a fast rotating globe, then wouldn't the oceans and other bodies of water be pushed away from the Earth in the same way as when a wet tennis ball is spun rapidly, the water sprays outwards? The scientists magicians have an answer for this. They call it gravity. If the Earth was actually a globe, spinning at a mind-numbing 1,000 miles per hour, how is it that we do not feel its motion? There is not a single person on Earth that can testify to feeling the Earth's alleged spin. We feel the motion when travelling in a car, train, boat, plane, and can experience motion sickness. The scientist magicians will tell you that we do not feel the Earth spin because it is spinning at a constant speed. They often use the analogy of a train ride. We only feel that we are moving when the train changes speed. This analogy, however, falls apart when you consider that in the heliocentric model, the Earth is not an enclosed system, but it is an open environment with its own drastically changing weather. If you were sitting on top of the train moving at a constant speed, and not inside it, you would certainly feel the motion. Furthermore, they also contradict themselves. In a 2016 article titled, NASA Study Solves 2 Mysteries About Wobbling Earth, they state that the Earth does not always spin on an axis. Instead, it wobbles irregularly over time, and that the direction has changed drastically due to changes in water mass on Earth. It's weird that no one has felt this. Which one is it, NASA? The stealthy, unnoticeable spin, or irregular movement patterns and wobbles? The whole notion of a spinning globe becomes absurd when you consider this. If the Earth was actually rotating,
I want you to notice the power lines move inward and lower to the ground the further they move out of your view. The same way with a long corridor or a hallway. And the same here with the street lamps. This is due to human perspective. And again here, notice how the railroad tracks merge into each other and then they eventually disappear and meet the sky at the horizon. And again here with the power lines, notice they move inward and downward until they eventually vanish out of your sight. As you can see from this point of view, the bottles are all lined up evenly. They're the same width apart and the same height. No fancy camera tricks here, just a phone camera. Now from this perspective, you can see that they all move inward and that they all get smaller in size towards the end of the table, and the table is flat. Now if the table were longer, these bottles would eventually disappear. That's called your vanishing point. Now the sun does the same thing. When you think you're seeing the sun set, you're only seeing the sun move out of your line of sight. That's called the law of perspective. As you can see here, the sun moves inward and gets smaller the further that it moves away from you. So the sun doesn't go over the horizon, it goes into the horizon. As you can see here, the street lamps are smaller the further away they are from you, and larger the closer they get to you. That works the same way with the sunrise. As you can see here how much bigger the sun gets the closer that it comes to you. Now technically the sun does not get larger, nor does it get smaller. It only appears to get larger and smaller as it moves in and out of your line of sight. Just as you've seen the power lines and the light poles do. The string is tied perfectly level across the counter, and the bottles are sitting level on the countertop. Now let's look at it from the same perspective. So as you can see, the sun doesn't set nor does it rise. It merely only goes out of your line of sight, moving beyond the vanishing point. Just as someone walking away from you. Now for example, as you can see right here, the field goal is at ground level and the bleachers are at ground level, but the man seems to be walking over a curve or down into the ground, but he is merely only walking out of your line of sight. The further he gets away from you, the less you see of him and the smaller he gets. Now the closer he gets to you, you see more of him and he seems to get larger until he's right in front of you. And that, ladies and gentlemen, is called the law of perspective. Thanks for watching.
This is the right spot. Look at this. This area is filled with books about pretend people.
That's right, Grover. This is the fiction section. Fiction means it's a made-up story. Oh, hey, Elmo, I bet we can find your galactic Gale
The big time boy, you're no longer on the ball. I'm just sitting here watching the wheels go round and round. I really love to watch them roll. No longer riding on the merry-go-round. I just had to let it go.
Friday, everyone. No, I was just recording, son.
Interestingly, recreating these parallel rays with a local light source isn't particularly difficult, as we can just use a lens. You see, when the lens is placed in front of the light at the lens's focal length, it actually collimates the light rays, which means that it makes them parallel. These newly collimated rays now have some of the characteristics of the sun, namely that the light intensity doesn't change because of distance alone, and shadows don't change in size either, which is super interesting to see. Another fascinating result is that anything at the lens's focal point appears to be pinned at infinity, and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project. Anything at the lens's focal point appears to be pinned at infinity, and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project.
I want you to notice the power lines move inward and lower to the ground the further they move out of your view. The same way with a long corridor or hallway. And the same here with the street lamps. This is due to human perspective. And again here, notice how the railroad tracks merge into each other and then they eventually disappear and meet the sky at the horizon. And again here with the power lines, notice they move inward and downward until they eventually vanish out of your sight. As you can see from this point of view, the bottles are all lined up evenly. They're the same width apart and the same height. No fancy camera tricks here, just a phone camera. Now from this perspective, you can see that they all move inward and that they all get smaller in size towards the end of the table, and the table is flat. Now if the table were longer, these bottles would eventually disappear. That's called your vanishing point. Now the sun does the same thing. When you think you're seeing the sun set, you're only seeing the sun move out of your line of sight. That's called the law of perspective. As you can see here, the sun moves inward and gets smaller the further that it moves away from you. So the sun doesn't go over the horizon, it goes into the horizon. As you can see here, the street lamps are smaller the further away they are from you, and larger the closer they get to you. That works the same way with the sunrise. As you can see here, how much bigger the sun gets the closer that it comes to you. Now technically the sun does not get larger, nor does it get smaller. It only appears to get larger and smaller as it moves in and out of your line of sight. Just as you've seen the power lines and the light poles do. The string is tied perfectly level across the counter, and the bottles are sitting level on the countertop. Now let's look at it from the same perspective. So as you can see, the sun doesn't set nor does it rise. It merely only goes out of your line of sight, moving beyond the vanishing point. Just as someone walking away from you. Now for example, as you can see right here, the field goal is at ground level and the bleachers are at ground level, but the man seems to be walking over a curve or down into the ground, but he is merely only walking out of your line of sight. The further he gets away from you, the less you see of him and the smaller he gets. Now the closer he gets to you, you see more of him and he seems to get larger until he's right in front of you. And that, ladies and gentlemen, is called the law of perspective. Thanks for watching.
Okay, I know you've been waiting for this. Now check this out. The clouds that look white don't show up in front of the sun because they're behind it. It's lighting them up. The clouds that are dark are on this side of the sun. That's why they look dark to you. Now, if you was on the other side of the sun, all these clouds that look dark to you on this side of the sun, well, they would look white to you if you was on the other side of the sun, just like these clouds right here on the other side of the sun that you looking at right now look white because the sun is in between the clouds. The ones that are behind it are lighting up white, but the ones that are in front of it are dark, and you can see them pass through it right here in the negative filter, plain as day, and the solar filter. But the white clouds don't pass in front of it, do they? No, they don't, because they are behind the sun. It's lighting them up. It's not lighting the dark clouds up because it's on the other side of them, and you're looking at it from the dark side. It's really, really simple. Now, this is only possible one way. As you can see here, you have the white clouds behind the sun, the dark clouds in front of it. Now, check this out. I have a piece of cardboard box cut out. I have one side of it on the light bulb of a lamp and one side on the other. It means the sun would have to be located here in the middle to cast light on the clouds behind it. But it can't cast light on the clouds in front of it. It's really, really simple. is one of the big questions I get about flat Earth is, for one, how does the flat Earth map work? It is, how do the seasons work? And also another question I get is, how come there is a 24-hour sun in the North Pole in the summertime and 24 hours of darkness in the wintertime? Well, it's really simple. Now, first of all, let me run over this with you really quick, because I got to get in bed and I don't have a whole lot of time. So I'm going to show you the map, which is patented on November the 15th, 1892. This is the version I have on my wall, but I took it off tonight so I can show you this really quick. As you can see, it's what, 10/4/1892. Okay, first of all, before I show you how this map works, what I want you to notice is over here to the right, you have the winter solstice, which starts on December 21st. Now, this right here in the center is the North Pole. Now, this little circle that you see right here with this illumination around it, that's the sun. Now, in the wintertime, the sun is out here. It's on its outer circuit, making its circuit around the Earth. It's further out towards the ice wall. Okay, now in the summertime, which would be your summer solstice, which is on here called the June solstice, and it explains to you pretty much how that works. Okay, and I don't have time to show you. If you want to get really good detail, just order the map. But anyways, notice how the sun here is closer to the North Pole, making a smaller circle than it does in the winter solstice, which is out here, which means it makes a big circle. Now, let me explain to you how that works. Okay, I'm going to turn the light off on this phone for just a second so you can see how this works. Okay, here we are. I've gotten it dark like it would appear in real life. Now, we're going to use this flashlight as the sun source. Now, in the wintertime, the sun is further out, which means, okay, here's the ice wall that surrounds the Earth. Let me get you guys familiar with this really quick, because I don't have a whole lot of time. Now, here's North America. Here's South America. Here's Africa. Here's third world countries, and here's Australia. Now, in the wintertime, the sun is out here making its circuit around the Earth, and it never changes up its speed. It's always going the same speed, but being that it's further out, it takes a longer time for it to come back around. That's why in the wintertime, your nights are longer than your days, because it takes the sun a longer amount of time to get all the way back around. Now, as the months go by and it starts to get into spring, well, guess what the sun does? It starts to move back in on its circuit. So that's why, notice when the sun starts to move in, see, say this is the daytime in America, which is right here in the summertime. Well, you have daytime there. Well, check this out. In the spring, the sun starts to move closer in. So guess what starts happening to this continent and this continent and this continent? Well, it starts to get warmer because the sun's moving in. That would be your spring. So now, let me fast forward really quick. In the summertime, the sun is all the way in here. Now, that's why your days are longer, because it doesn't take the sun very long to get back around to you. So the nights are really short and the days are longer. Doesn't mean the sun's moving faster, it's just on a shorter circuit. Doesn't take long to make that circle when it's making a small circle. You guys see what I'm saying? So in between the winter solstice and the summer solstice, you have this in-between time, which is right in here. Well, in the summertime, it's really hot here in America. Okay, so in the fall, well, the sun starts to move back out. So this in-between right here, this is your spring and fall. This in-between time when the sun starts to move back out, guess what? It starts to get colder because it's moving further away from you. Now, notice everybody's like, oh, well, the southern countries are always hot. Well, it's really simple. You got South America, you got Africa, and you got Australia, and it's usually always hot in those areas. You know why? Because they're usually always under the sun as it's moving back and forward on its yearly circuit around. Now, it's really simple, and that's how your seasons work. In the summertime, it's a small circle, just like this right here. That's why your days are longer and your nights are shorter. Well, when the sun moves back out, notice how your days start getting shorter. That's because the sun's starting to make a bigger circle. And then in the wintertime, your nights are really, really long and your days are short, because it takes the sun a long time to bring its light back around and its heat back around. But its heat is way out here, and that's why it's cold here in the wintertime. But say in South America or Africa, it's not really cold in any of those months, because the sun is always over them, no matter if it's here or no matter if it's here. It's always over these countries. Now, your midnight sun, which is a 24-hour sun, and I think that for 187 days, which is a little over 4 months, which makes sense. You know, a summertime is about 3 months, a little over 3 months long. So as it fades back out, well, now, here's my point. If you're in the North Pole has 187 days of daylight, okay? Well, it's really, really simple. Look at the North Pole. This is the North Pole. In the summertime, the sun's on its short circuit, so guess what stays lit up the whole time? Even though the other countries over here are dark and the United States is lit up in the daytime, these countries are dark. Well, guess what's still lit up? The North Pole, the Arctic. No matter where it is, its circuit is so short, it keeps it lit up the whole time. And then you have 163 days, I believe it is, of darkness in the North Pole in the wintertime to us here in the United States. So in the wintertime, guess where the sun is? It's out here. So look at the North Pole. For all those months, it has no light because the sun is out here making its circuit. It's really, really simple, guys, once you understand how to read this map. And right here, it's very, very simple. That's why it says right here, longitude and time calculator. This tells you how the months work, and it tells you how the time works. Now, up here you have the morning, and over here you have noon, and right here you have evening, and right here you have midnight. So notice in Roman numerals how it goes 1 all the way over to 12, and then it starts over again, 1 all the way around to 12, because half of the earth for 12 hours is lit up. So let's say from morning all the way around here to evening. Well, over here it's midnight. That's why it says midnight there, because it's dark there. The sun is on this half of the earth, and then when it moves to this half of the earth, this half over here is dark. That's why it's numbered the way that it's numbered: morning, noon, evening, and night, midnight. That all the ancients knew this for years and years. And that's why this map, if you look at the very top, it says scientifically and practically correct as it is. Now, if you're wondering why the map says time calculator, well, it's really, really simple. For thousands and thousands of years, all the ancients used a sundial to tell the time, okay? Now, you have to remember this. They even taught you this in school, that the sundial was used to tell time. Now, if we use a ball, a spinning ball, and the sun, it doesn't work. But I'm going to show you how this works. Check this out. It's really, really simple. Okay, hold on just a second. Okay, we're going to use this pencil right in the center of the earth at the North Pole as our sundial. And I'm going to show you that why this says time calculator. Now, let's say this is the sun, and remember the sun revolves around the earth clockwise. So here's our shadow from the sundial in the center of the earth. Now, as the sun makes its rotation, watch what the sundial does. What's it do? It tells the time: 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. As the sun makes its circuit, that's how the sundial works. You see where I'm coming from? Now, when it's dark over on that side of the earth, it's light over here. You see, the sun has to make that circuit to make that sundial work. It's really, really, really simple, guys. Really simple. That's the only way it can work. The sundial does not work on a spinning ball. So if it doesn't work on a spinning ball, then that should tell you that the Earth's flat. Either the Earth is not flat, and for 5,000 years people were telling time the wrong way. And I don't think that that's very possible at all. Thanks for watching, guys. One of the most common questions I am asked is, how does an eclipse work on a flat Earth? Well, to be honest, it's really complicated unless you understand how close the sun and moon are to the Earth and the path that they take. Now, NASA and science tell us that an eclipse occurs when the moon gets between the Earth and the sun, which is true. Now, let's give NASA the benefit of the doubt and test their theory really quick. The sun is supposed to be 400 times the size of the moon. Okay, so here I have a flashlight representing my sun source and a penny representing the moon. And as you can see, the flashlight is a lot larger than the penny. Okay, now let's place the sun 93 million miles out into space like this. And let's get our penny a lot closer to the camera. Okay, where it's about the same size as a flashlight in perspective. Okay, now that doesn't look right. You can't see the corona, and it just doesn't eclipse. You can still see it light all around. It's not a total blackout like you see here in the 2017 total eclipse. Okay, now you guys seen that. That just did not look like an eclipse at all. Okay, now I have a side light on the side of this flashlight that just so happens to be the exact same size and diameter as the penny, which is perfect for our next test because the sun and the moon are the same size on a flat Earth. And we'll bring the sun in closer to us as it would be on a flat Earth. Now let's try our eclipse with the moon right underneath the sun. And wow, there's the corona. That was fabulous. Now let's compare the 2017 eclipse with the demonstration that I just showed you. That was really, really close, almost identical. Okay, now I'm going to show you how the eclipse works on a flat Earth. The sun and the moon are kind of like the minute and the hour hand on a clock. The sun being the minute hand and the moon being the hour hand. The sun will eventually pass over the moon as the minute hand will eventually pass over the hour hand, causing what we see as an eclipse, as you can see right here in the illustration.
In just a few hours, the moon will pass completely in front of the sun, that event called totality, casting a shadow about 70 miles wide. The so-called path of totality spanning 14 states from Oregon to Charleston, South Carolina, where we find world news tonight.
Now I'm just going to show you really quick how the eclipse went from the west coast of Oregon to the east coast of South Carolina. Now, as you know, the sun rotates around the earth in this circuit. Now we're going to use the penny as the moon, and I'll show you as the sun moves across the penny, it causes the shadow across the United States in the same pattern that the lady just showed you on the news. And that's how the eclipse works. Thanks for watching, guys. Good afternoon, everyone. Just wanted to do a really quick video on the sun speed because it seems like there are still a lot of people who do not understand the speed of the sun. A lot of people think that the sun has to speed up in its winter solstice, and it doesn't, of course, and I'm going to prove that to you right here. With the Hammond's Air Age Map of the World, which is an old map the Air Force used back in the day. As you can see here, the white ice wall says Antarctica. You can see the time zones. If you go down here at the bottom, you'll see it again, Antarctica with the time zones. Perfect white ice wall all the way around. If you look at these little red lines all over this map, these were the actual flight routes in 1903 when this map was made. But what I'm going to be showing you here is how the sun revolves in a circuit around the flat earth, just like the hand of a clock. The only difference is in the summertime the sun is lower in its summer solstice, so that's why you see this mechanical hand that I've made look like this. And up here is the sun in the wintertime. The sun ascends upward higher in the air in the winter than it does in the summer. That's why it's a lot colder in the winter. The sun is higher away from you and it's further away from you. So I'm going to demonstrate to you how the sun ascends in its winter solstice and descends in its summer solstice. All the while it's making its circuit around the flat earth and keeping the same speed all year round. Just like when I hold this flashlight close to the floor, you have a small circle of light, but it still moves around in a circle at the same speed. Now, in the winter solstice, the sun ascends higher into the air and its light covers a larger area as the sun makes its circuit, but it still comes back around to its starting point within a 24-hour period. Let's turn the lights out. Now, as you can see here, when I cover this light, this is your summer solstice right here. It's very small circuit and very close to the earth. Now, watch when I cover the summer solstice up. Now, here's your winter solstice. The sun is higher, so therefore it covers a larger area. Okay, now here is your summer solstice right here. Notice how it makes a small circle and the light is very bright and close to the earth. Okay, now here is your winter solstice. This is when the sun ascends higher and moves further away from you. Now notice how much of a larger area that its light covers in the winter. That is how the sun still makes its circuit within a 24-hour period. It doesn't change its speed, it simply raises up higher and its light spreads out further. Now here I'm demonstrating the summer solstice and the winter solstice at the same time. Notice the summer solstice is closer to the map and it's brighter and makes a small circle. And notice the winter solstice is higher and its light covers a bigger distance. But the sun still completes its circuit within a 24-hour period. Just like this second hand I told you before, whether the sun is at the tip of the hand or at the center of the hand, it still will complete its circuit within a 24-hour period. Just like this hand on this clock will complete its circuit within
60 seconds. That's called angular speed, which gives the rate at which a center angle swept out by the object changes. The object moves around the circle and is thus measured in radius per unit time. Now I'm going to show you my demonstration alongside a clock. I'm going to show you that the hand on the clock and the hand on the map that I made, they both reach the 12 o'clock position at the same time. The center of the hand and the tip of the hand reach the end of its circuit at the same time. It does not change its speed. The only thing that changes is the sun's light, because it ascends up and it ascends down as it makes its circuit. And it's as simple as that. Thanks for watching, and God bless. Now, as you can see here, the sun rays are coming out right here to the left at around a 7.2 degree angle. Now, right here in the middle, they're coming straight down. Now, when you get back over here to the right, they're coming back out at a 7.2 degree angle. Now, a little bit of calculation will show that a 7.2 degrees on each side coming up to a perfect triangle puts the sun at about 4,000 miles up into the sky. Now I'm going to prove that to you really quick. Here I have a piece of cardboard that I have cut the edges out perfectly on the edge of this cardboard. Now over here we have a flashlight, and if you look right in front of the flashlight, you will see a perfect 7.2 degree triangle leading right to the edge of the flashlight, the light source itself. So when you look up into the sky and you see where that triangle comes up and meets to a point, that is where your light source is located. So like I said, we have this flashlight in which we're going to use as our sun source. Now, let's go over here and turn the light out. Now, check this out. Notice that the shadow of the edges of the cardboard are parallel with each other. That would be 93 million miles away. They'd all be parallel with each other. Now, let's watch what happens to the shadows of these edges when I move them in close to the light source. Remembering that the piece of cardboard represents our cloud. Now, about right here is a 7.2 degree angle. Now, if you don't understand this, apparently you failed science and physics. This right here proves that the sun is only about 4,000 miles up in the air, just right above the clouds. That's the only possible way to get crepuscular sun rays. Anyways, I'll let Professor Leo Ferrari explain it to you simply.
Does running round your neighborhood prove that the neighborhood is round?
Dr. Leo Ferrari explains.
Oh, the Eratosthenes experiment is an experiment supposedly conducted in the 1st century, whereby this ingenious person was supposed to have proved, I say that in quotes, that the Earth was a sphere of some 4,000 miles radius. Eratosthenes one day noticed that the sun was directly overhead in Syene, whereas he noticed that on the same day, at the same time, the sun made an angle of 7.2 degrees to the vertical at Alexandria, which was some 530 miles away. How did Eratosthenes in the 1st century know what the sun was doing on the same day in two places which are 530 miles apart? One can take all those same data, knowing that the Earth is flat. In one place you have the sun directly overhead, and at another place at the same time, at 530 miles away, let us suppose that it does make an angle of 7.2 degrees to the vertical. Then we have a right angle triangle, which it can be easily shown that the sun is some 4,000 miles up in the sky. With a sphere of 4,000 miles radius being spun round once every 24 hours, a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour, and it doesn't know it. I mean, this is obvious nonsense. You go on a merry-go-round, and it goes, I doubt, more than 10 miles an hour, and you get off all dizzy. You mean to tell me that people can be spun round at approximately 1,000 miles an hour and not know it? Why, if this is so, this whole room that we're in is supposedly being spun round at something of approximately that order of speed, and we don't know it. These superficial, even, considerations show that it's impossible. The whole thing, it's a story, a fairy story made up and mindlessly repeated in textbooks.
Fredericton author and teacher Leo Ferrari died this week. We last spoke to Leo Ferrari in April of 2005. He had Alzheimer's disease. He spoke about what was happening to him at every opportunity, including an attempt to slow the process with the drug Aricept. He and his partner, Lorna Drew, wrote about the subject, offering suggestions for others entering into that world. Ferrari was a retired scientist, philosophy professor, and world-renowned authority on St. Augustine. He is the author of numerous scholarly books and 2 collections of poetry. Ferrari passed away on Tuesday in Fredericton. He was 83.